All right, welcome to the February edition of our webinar series, the Journal of Statistics and Data Science Education webinar series. I'm Lee Johnson, I'm your host. We're gonna be talking about bringing visual inference to the classroom today with Adam Loy. But as again, I just always wanna do a couple of announcements before we get into the actual webinar. So we'll do that. And so if you haven't looked at the website lately, if you haven't looked at the journal lately, these are some of the articles that just came out that are listed as the latest ones. We actually do have a new edition, like on its way to press, so that should be out very soon. But some interesting things kind of coming up. Data science program for middle grade learners. That looks really interesting. Oh, of course, I'm having slide issues. And then an alternate form of the one-way ANOVA and Kruskal-Wallis test. So some good stuff in there. All right, so be sure to check that out. Details will be coming soon for the March webinar. We're just finalizing those behind the scenes, so stay tuned. We will have an announcement go out as soon as we have that finalized. The big thing is ECOTS is coming up, so news from CAUSE. The actual dates are May 23rd through the 26th. There will be pre-conference workshops. And I know if you're on the listserv, you got an email from Megan Motko in the last couple of days. If you are planning to do a regional conference, the proposal is due today. So you may want to get on that now. That I know I've done one at Ohio State. Sorry about the slides there. I know I've done one at Ohio State for ECOTS before, and it is really a nice way to sort of supplement ECOTS. And then if you are planning to do a virtual posters and beyond or a birds of a feather, those proposals are due March 13th. So make sure you have that on your calendar. And as always, the USPROC competition is ongoing. I know they're reviewing the entries for winter at the moment. And so the deadline for spring is toward the end of the semester. You can, of course, go to the website and check out the exact requirements and the dates at the website. All right, so getting to our webinar. So Adam Loy is an assistant professor of statistics at Carleton College in Northfield, Minnesota. So he's probably colder than I am right now. He received his PhD in statistics from Iowa State University. Adam's research interests include incorporating realistic computation and visualization into the classroom, exploring the potential of visual inference, developing better visualizations to explore complex models, and developing useful and usable R packages. All right, so we're gonna just very quickly do a little technical thing here. So Adam can show the slides from his end. And then Adam, I'll let you take it away.
All right, thanks, Lee. Can you see my slides okay?
Mm-hmm.
All right, awesome. And so I'm going to be talking about bringing visual inference to the classroom. And I just wanted to make sure you had my contact info to start out. So you can always feel free to email me if you have questions afterward, or look at my webpage, and there are links to the article and other things that you can check out there. And let's see here. What I want to start out with is something we all know about, that we've had this move to a simulation-based curriculum since 2007. And so we saw this shift in the first course, or the intro course, to begin with. And then we started to see these validation studies from Tintle, Maurer, and Locke, and Hildreth. And I'm sure I'm missing some now. And so we were pretty sure that this is reasonable at building intuition in our intro students. And then we've seen proposals to use it in other courses as well. So in statistical inference types courses, or math stats, Cobb talked about it in 2011. And the same year, Chihara and Hesterberg published a textbook where they introduced confidence intervals and hypothesis testing at that math stat level, using the same approaches that we're seeing in the intro stats level. And then in 2015, Tintle and co-authors talked about the applications throughout the curricula that we have. And what I'm seeing as I look back through this, and I've incorporated these ideas into my own courses, is that all of these approaches pretty much have a similar approach to visualize the inferential process to start out with. And so that's where I was starting my thought process here. And in order to anchor our discussion today, I'm going to use an example that comes to us from Shonda Kuiper and Sklar's textbook in 2013. And it's this Shapesplosion game. And I have an example of the game board coming up here. And you can think about it as an intro stat type project where we're trying to figure out whether or not distracting colors would influence the time to complete this Shapesplosion game. And so we have 40 total students in the class. We randomly assigned 20 to the standard game, 20 to the color distractor group, and had the students play them in the same similar background noise, similar conditions, perhaps during class time. And then you collect the time in seconds required to complete the game. And I'm just using the data set that Kuiper and Sklar have available. So I'm not trying to claim any sort of ownership or credit for that data set. And you can look at the game here on the Stat2 Games website. And just to make sure that we're linking to what this is, the top two panels here would display the standard game where we have these pink shapes and pink sockets or holes that those are going to go into. And the bottom row, we see these color distractors. So if you look at the top left shape, maybe this flag type symbol, its color is different from the socket it's going to go into over here. So one's black and one's pink. And so the idea is that this could impact the time to completion. And Kuiper and Sklar talk a little bit more about the background, as does the website. And what I would do with this type of initial discussion, I'm thinking about introducing inference. And so I'd turn to my students and say, okay, I've introduced the data a little bit. Go discuss what the competing claims are that we want to investigate in this study so that they can start to hone those inferential thought processes. And I might also give them, for instance, a sample statistic such as the difference in mean completion times, where the color distractor group took 2.55 seconds longer. And I'd ask them what the sample data have to say and maybe what that means. And this is what I've done for a while. And when I first started the simulation-based approach, I would go to something like StatKey Next. And we'd have our original sample up here in the top right. Of course, we'd be re-randomizing. So we're shuffling those standard and color distractor labels. And then we're talking through randomization sampling, and we're building up this randomization distribution. And I like StatKey. I'm not trying to say that there's anything wrong with this type of app, but what I started to see in my students was confusion as we were building up this randomization distribution at the beginning. It felt like we were going a little bit too quickly when we were still trying to build that logic. And, you know, thinking about dots on this plot seemed to just throw them off. And so I had to think about another way to introduce this. And what I came up with was perhaps we can use this lineup plot where we're using Sesame Street type logic about which plot is most different from the others, and then have them justify their choice. So instead of trying to introduce that randomization distribution, what I'm trying to do instead is have them think a little bit differently just in terms of what the sample data actually look like, and focus on that rather than going straight to the statistic. And so just to give you a little bit of experience interpreting one of these lineup plots, I thought I'd give you maybe 30 seconds or a minute to take a peek at this. I didn't show you the original plots intentionally, so you wouldn't necessarily be able to as easily detect the data set. But take a look at this and just think about which one of these panels is most different. Should also say that these dots near the median are the sample means.
Yes, maybe feel free to put your answer in the chat. We have
No, that's a good idea.
At 11.
So I see an 11 and a 9 and a 6 and a 7 and 6s and 9s, 11s. 13, 7, 11, 6. It's looking like a lot of folks have had some time to digest this. And it looks like there's a variety of opinions out there. And so if we actually go and look at which panel displayed the data, I am highlighting it here in this gray background. And so it's panel 13. And so this is the type of activity that I'm starting out with. I'll unpack how that works and the flow of it in just a little bit. And so you can start to think about what we've actually just done and how that's going to link to our intuition building goal for inference. And so let's do that. So what did we do? Well, we compared a data plot with a set of decoy plots where we know that those decoy plots were generated under a situation of no association between the treatment group and the time to completion. We were forced, as we were looking at this plot, to make decisions through comparison instead of just looking at an individual statistic or an individual plot, which is exactly what we want to be doing. With that inferential thought process, we want to understand the behavior of these metrics, these measures, these pieces of evidence, if in fact the null were true. And all of this can be done pretty quickly with minimal, I would say, technical details in the background, because it's using the Sesame Street logic that our students have been using for a long time, ever since they, if they watch Sesame Street, that they, selected which of these balloons is not like the other, whichever episode you're watching. And so it seems pretty easy to get the conversation rolling that way. And I want to unpack the activities workflow a little bit, and then before I move on. So, and so I provide that brief overview of the logic of hypothesis testing. So some of the steps in terms of why we need to write down our claims, what evidence is. This can be done through group discussion using some of those questions that I talked about at the beginning. But you want to make sure that you're going through the basic steps of the logic there. And then I do a very quick discussion of how the decoy plots are created on these lineups. Generally, I'm just saying that there are decoy plots that are aligned with our null, but I'm not getting into any of the technical details in terms of how those are created. And students seem to buy into that pretty easily. Whereas if you're showing that app and building up that randomization distribution, it seems more important to them how all those things are happening. Of course, we go in later after we build that basic intuition in terms of filling in those technical details. And then what I do is have the individual students evaluate the lineup and maybe give them 2 or 3 minutes, because I have them not only select a panel like you all did, but also write down why they chose the panel that they did, so that they're starting to organize their thoughts about what stood out to them or what signal that they're focused on. And then they turn to their groups and discuss this before we regroup. So the groups come to some sort of consensus, or maybe the consensus that they have no idea what the consensus should be. And then we reveal the observed panel, and I have the groups go discuss again. So what are the implications if your group chose the true data plot, or whether what are the implications if you didn't identify that plot? And then after that discussion, we regroup, we debrief, we go through the logic of hypothesis testing again, and then we start to fill in a couple of the formal details there. And so that's the basic idea, and I'll have a link to the website where you can see the actual activities. And so what I thought might be useful at this point is just kind of putting this, I'm going to say, line up this visual approach side by side with the simulation-based inferential approach, which we've been using in intro stats for a little while. And so just working through showing the parallels in that intuition, or in that logical framework. And so we start, of course, with our hypotheses, and they're going to be the same regardless of what setting we have here. So I just kind of have it spanning both columns. So we could have equal means, of course, that might be in context. And then the alternative is that there might be the mean is larger for the color distractor after the groups talk about it and think that that's going to be harder rather than just some effect. They can be more specific. And then we need to quantify our evidence. related to our competing claims through a test statistic. In the simulation-based approach, we just have some function of our data, such as a difference in means. But in the visual setting, we can just use a single plot. It could be a set of box plots. It could be a set of histograms, density plots, whatever you're using in your course. And then we need to think about understanding the behavior of this test statistic if in fact the null were true. So we're building this reference distribution. In simulation-based inference, of course, we have this randomization distribution, and we have to talk through how that's created. In the lineup or the visual setting, we're going to have a field of decoy plots where they're generated with nothing going on. And you can choose the level of detail in terms of what that means to be a decoy. But again, you're only showing a small snapshot of that reference distribution here in the left column, and that helps students focus in on what's going on with the sampling variability as you go sample to sample when there's no association. And then you talk about what the evidence means, evidence against the null is. So if we're in the randomization setting, we're going to be further out in a tail or tails, depending on our alternative. And it's going to be whether or not we identified the true plot in that lineup if we are using the visual setting. And so there are these parallels, and you can draw these parallels as you introduce the more formal test. And that what I found in the couple of terms that I've done this with my class is that as the students are looking through this randomization distribution, whether or not you're using dots or histograms or what have you, you can always go back to one of these lineups and talk about what one of these decoys meant. And that's a dot on the dot plot or a count on the histogram. And so that's where I've used it in intro stats to begin with. And it's useful other places too. And so I thought I'd briefly go over some other places I've used it in my courses. And when I think about this, it's anywhere that students might suffer from apophenia, which is the tendency to perceive a connection or meaningful pattern between unrelated or random things. And so when I think about when students might suffer from this, the first place I go to is the interpretation of residual plots and, the verbal gymnastics you can get into trying to describe no association or random scatter. And then when students get to those first couple residual plots, the fact that we can see patterns everywhere. And so if we embed, for example, panel 3, which is an observed residual plot in a field of decoys, where you have the same number of observations, these are generated, you could use a residual bootstrap or a parametric bootstrap. There are differences there. But you can generate data through your model so everything is appropriate. And you can then have conversations about whether or not any of the structure students tend to see here is important in indicating a model deficiency. You could also use it to just help students interpret unfamiliar statistical graphics. So if we take a look at an example from the 538 package and thinking about whether or not it's rude to bring a baby on a plane and whether or not those opinions vary by someone's self-reported gender. You could say, okay, well, you might use this example to introduce stacked bar charts or mosaic plots or ideas of association. And the question becomes down here in panel 19, that's our observed plot. And there's a difference here. There's a little step up. The blue bar is a little bit larger on the right. The orange bar is a little bit larger. The black bar is a little bit smaller. But is that really indicative of a strong association? And so you can start to help students interpret those things and see what structures or lack of structure means in these plots. If you're thinking about another course that's not intro, maybe you teach logistic regression in Stat 2. And if you teach out of that Stat 2 book, then you might use the empirical logit against a predictor variable in order to diagnose the linearity of your odds. And so panel 7 here is an example plot that they show in that Stat 2 textbook. And when students first look at this, it might be a little bit hard to interpret because we only have 5 points or so here. And now that I said that it's in the book, I don't remember if this is the exact one or just a different binning that I used. And so again, embedding this in a field of decoys helps students say, well, is it reasonable to say that this is somewhat curved because I have 3 points below the diagonal here and the other two are above. And it's really just helping force those comparisons that we want to hone through repeated practice. Finally, you can tease out more advanced statistical topics or use these in upper level courses too. So Wickham and others in 2010 in their InfoVis paper were using statistical visual inference to explore spatial associations in Texas. And so if you're thinking about a spatial course or pitching a spatial course to your students, you could use these ideas, or even just to help them explore what an association might look like in an intro course or a data science course. So I don't want to go on too long, and I want to make sure everyone has a chance for questions. So just a quick recap of my main points. I think that the visual inferential process through the lineup protocol introduces students to the logic of testing without the need for a lot of technical discussions that I found myself getting into too quickly before I used visual inference. It provides a framework that we can use outside of testing as well in order to introduce unfamiliar plot types, new statistical graphics, or model checking procedures. And it also provides a rigorous tool if you wanted to use it for later statistical investigations in your curriculum. I don't want to leave you without any resources for this idea. And so you can certainly look at the JSDSE paper that I have out there, and it links to a lot of these resources as well. But here's the URL to the web page associated with that paper, the supplements that I've created. So I have 2 activities out there with instructor guides. I have a tutorial on creating lineups in R using the nullabor package. I think I was using GG or formula there, but I can't remember the plotting engine I was using there, but I probably use a couple other tidy tools as well. And I also have a small suite of Shiny apps that help create lineups for class activities if you just want to do it quickly to see how it works before you kind of dedicate your time to exploring how to do this in R. And so hopefully you got a gist of the idea and the activities you could create, and I'm happy to answer any questions you have.
So if you have questions, feel free to put them in the chat, or there is a Q&A option here as well. You can always put them there. I think people can unmute if they'd like. I'm not sure. So I was going to ask one question. I was actually going to ask how you put these together, but you actually provided the tutorial for the R. Like, how long does it take you to put one of these together?
Not very long. I mean, so the nullabor package provides the simulation routines for some of the typical situations we'd see in intro stats, for example. And so it can reshuffle columns. It has some functionality to reshuffle columns or resample residuals. And so in terms of, it's going to take a couple minutes to digest the R code, and longer if you're not an R user. But once you kind of have it, it's mainly just subbing in a new data set, replacing column names, and then you're good to go.
Okay.
In the Shiny app, you can just upload a data set and it'll do the work. You'll have to specify, what your explanatory and response are, but it'll give you some options there.
So it was interesting. The first one you did, I've actually used that data set, and then everybody sort of had a different response as to which one was different. Have you done ones where it's, because if I remember correctly, the difference is not significant for those 2 groups. Have you done one where it's a little bit more, I want to say, obvious?
Yes. And I think that's a very good point. You want to do one, you can choose whether or not you want one to be easy at first pass or hard at first pass. I often have one that's a little bit, harder or borderline to show students that, oh yeah, we saw just the, 2.55 is not 0. But we couldn't really perceive, there was no discernible difference there when we looked further. But then you want to follow it up. And so generally I would follow it up maybe with a homework question, or depending on how much time I have and how long-winded I get, I do one that's more obvious as well. Absolutely. And so usually the obvious ones are really quick, and there isn't as much disagreement or that we saw in the chat. Yeah.
Okay. Well, I'm not see necessarily any questions at the moment. Okay, well, if there are no questions, thank you very much for sharing this and sharing some of the, we weren't able to mute, oh, but it was, okay. Sorry, yeah, sorry, I'm still sort of learning the ins and outs of this. But thank you very much, Adam, for sharing this. And obviously, everyone, you have some links that you can go to and kind of explore whether you might want to try this in your own classroom. And thank you to everybody that came out. The recording will be posted shortly, as well as the slides, so you can go back and look at all of this. And otherwise, I hope everyone has a wonderful afternoon, and we will see you in a month. Hopefully.
Thanks, everybody.
Yep.